Hey everyone! Today we're going to be going over LeetCode question number 56, merge intervals. This is a level medium problem and it's not too difficult based on the solution that you use, and it's sort of intuitive, so hopefully you all get it. We could start by reading the prompt and then we'll dive into the examples and look for a solution. So, looking at the prompt here, given an array of intervals where intervals I equals start and end, merge all overlapping intervals and return an array of non-overlapping intervals that cover all the intervals in the original input. Looking at some of the examples here, we see that we are essentially given a 2D array with these individual subarrays being what the problem is calling an interval. And each interval is essentially, or each subarray has a length of 2, where there is the first index is called like the start of the interval, and the second index is considered the end of the interval. So looking at this input here, we have this one array, and in it we have a subarray, which is an interval that starts at 1 and ends at 3. Similar here, there's one that starts at 2 and at 6, 8, 10, and then 15 and 18. And essentially, we want to condense this and merge all of the overlapping start/end times together. So that our output, for example, here would be 1 and 6, because essentially 1 and 3 and then 2 and 6 can be merged together, since 3 is greater than 2 over here, and it essentially would overlap in terms of time. So in this output, we merge those two intervals here, and we get 1 and 6, and then 8 and 10 and 15 and 18 don't overlap, so those kind of remain the same. Here, just a smaller example, we see that we have 1 and 4, and then 4 and 5, and because the end time here and the start time here are essentially the same, they overlap, and we get 1 and 5. So that that time interval was just start time was 1 and time was 5, instead of having those two individual intervals that were given in our input. Hopefully, from this, just my explanation here, you're starting to get a better idea of what logic needs to be used to solve this problem. But let's dive a little bit deeper and look at the whiteboard. So over here, looking at the first example here, we see that, okay, we have 1 and 3, 2 and 6, etc., etc. If we kind of look at the first two in our example, 1, 3, and 2 and 6. I kind of mentioned this before, but what essentially defines how when to merge? Why do we want to merge interval? What are the rules that we're looking for here? If we see, essentially, the reason we merge this is because the 3, which is the end time of the first interval, is greater than the start time of the second interval over here, 2. So, in this case, 3 is greater than 2. That's why we know that there's an overlap. So, essentially, 1, we could start at 1, and we could go all the way to 6, which is the end time of the second interval, just because the 3 here is greater than 2. Similarly, if this was, instead of a 2, 3, if this was a 2, we know that there's obviously a merge, because this ends the same time that this starts. So we also know that if it was 1 and 2 and then 2 and 6, that would also be considered a merge. So going off of this logic and this ruling here, we can essentially say that when do we merge? Let's see. Merge when end time of the current interval int for short. So, in this case, our current interval is 1 and 3, is greater than or equal to the start time of the next interval. And in this case, the next interval being 2 and 6. So as long as we follow this rule and we check for the end time of the current interval and the start time of the next interval, and it's greater than or equal to it, we can essentially assume that a merge will occur. We're going off of that rule here. Now, there's a few things we need to do and arrange our intervals so that we could do this in a uniformed manner. That is, we have to make sure that our intervals are sorted in some sort of way. So just some steps that I'm going to write down here. Steps. So essentially, one step is that we need to sort. I'll put int for short here for intervals uniformly. And how we essentially sort it is, and like the examples that they gave, they kind of helped us out here, but we would sort them based on the start time. We want to make sure that the intervals are sorted from smallest to greatest start time, so that we can use our logic that we just mentioned here accordingly. So for example, if instead of 1 and 3 and then 2 and 6, instead if it was let's put it up here. If it was like 1, 3, and it was like 8, 10, and then it was 2 and 6, you see that the start time is not sorted. Like it's like 1 and then 8 and then 2. We couldn't follow this logic, and we wouldn't have a good way of iterating through all of the intervals, because we would just be like, okay, it's 1 and 3, then obviously 3, it's not greater than or equal to 8, it's less than 8. So we'll be assuming that, okay, 8 and 10 is just the next interval, and then we come across 2 and 6 here, and there's no easy way to just go back and modify this interval here, saying, oh, okay, there's 1 and 3 here, 2 and 6 here, let's just kind of change this to like 1 and 6 or something. There's no good way to do that. That's why we need to sort the interval uniformly on start time. Next, we kind of follow the logic I mentioned below. Follow greater than or equal to logic based on start time and end time. And so like, what happens if we see that two intervals have met the conditions of our logic? What do we do after that? Essentially, if like the condition is met, we want to just get the max end time of our interval, like for our final merged interval. So for instance, going back here, like 1 and 3 and 2 and 6, we see that they overlap, and we want to get the max. So we get the max of the end times, which is like 3 and 6, and the max is going to be 6. And then our final merged interval is just going to be 1, 6 interval. Say, for example, let me just kind of scroll down a bit. Say we had 1 and 7 as one of our intervals. This is a 7. And we have the same interval 2 and 6. obviously 7 is greater than or equal to 2 and 6. And when that condition is met, we want to get the max of the n times as I just mentioned. So the max in this case would be 7. So then the final merge interval would be 1 and 7. And in this case, this would essentially just disappear. So that's why we want to get the max of the n times, because we don't know which interval of the two is going to have the largest n time. It could be the current interval that we are viewing, or it could be the next interval that we are viewing. So we want to check both of them. So, steps here, as I mentioned, we sort uniformly on the start time, follow the greater than or equal to logic based on the start times and end times, and then if the logic is met, then we get max end time for merged interval. Just like I mentioned here, we just get the max of 7 and 6 in this case, or in this case it would be max of 3 and 6. So these are essentially the steps that we will follow. Maybe we can start coding it now. Okay. So the first thing we want to do in terms of coding this up, looking at the steps here, we want to sort it uniformly based on the start time. Using a Pythonic method of sorting, it's quite simple. We could just do intervals dot sort, and to ensure that we are sorting it on the start time, I believe by default it'll sort by the first element if we're given a 2D array for each subarray. But just to be sure, we can use a quick key with our lambda and have it just point to the first index of each subarray which is x is 0 in that case, just to be sure. Now, our intervals are essentially sorted. We can move on into iterating through them one by one. Before we start iterating one by one, we should have our current interval set, and then we're gonna keep going next interval, next interval, next interval. So we're gonna have our merge intervals together. So I'm gonna call this new 2D array new intervals, and for this we are going to initialize it with the first interval in our new sorted interval array, and that is essentially going to be our current interval. Let me just make a comment here. Set current interval. So this is going to be our essentially what we are going to be outputting. So this is going to be the first element in the sorted intervals array, which is interval 0. So in this case, since this is already sorted, new intervals, it's going to start off with 1 and 3. So we are given, we're going to give it the current interval. Now we could start iterating through them. For I in intervals, and here we are going to skip the first one because we already set it here in new intervals. That's our current array. So we're going to skip the first one, and we're going to go from index 1, which is going to be 2 and 6, from index 1 and on. That's what this essentially this means. We're going to go from index 1 and beyond to the end. So we're essentially just skipping the first one since we set it as our current one. So now we can, we've sorted it, right? Now we could follow the greater than or equal to logic that I mentioned here. Merge when end of the current interval is greater than, end time of the current interval is greater than the start time of the next interval. So implement greater than or equal to logic based on start and end. times. Now for that, we could have a if statement, if new intervals. So essentially the current interval, right? We want the current interval, and to get the current or latest interval, we will always want the last or latest subarray that we've added to our new intervals array. So, this is going to be our, as I mentioned, our output array, and we always want the last element of it. That's why we're going to put a -1 here, because in Python, if we put a -1, that's just going to give us the last element of the array. So for the first iteration, the last element of the array is going to be the first element, which is 1 and 3. But as we go on and on, say we've added a few more, like we have 1 and 3, we have 1 and 6, we have 8 and 10. We want to get the last one, so we want to compare 8 and 10 as the current one with 15 and 18. So that's why we're just going to get the latest one, and that's why we're putting a -1 here as our last element of the new intervals array. And as I've mentioned here, we want the end time of the current interval. So the end time is going to be always the second index, or 0, 1, 0th index. The first index is the end time. So that's why we are defining the index 1 here for our end time. So basically, if the end time is greater than or equal to the start time of the next interval, so I in this case is the next interval, I, and then 0 is going to be the start time. If that's the case, then what we're going to do is we're going to take new intervals, and we're going to take the last element of it, and the end time, we here, just adding some more commas to be sure. So basically this is the end time of current interval, and what I and 0 is, this is the start time of the next interval. Okay? And then, what we're going to do based on our logic I mentioned here, we take the max end time of the merged interval, and then we add it to, or we just update the interval, the current interval, with the latest or max end time. So this is we're just updating the end time of the current interval here equals max. We take the new intervals, we get the end time of the new interval, and then here it's going to be I of 1, because we want the end time of the next interval as well. So this is just getting the end time of the current interval, end time of the next interval, same here, 7 and 6, or 3 and 6, and we're just getting the max of it and updating it. That's all we're doing here. Else, so say it's not a mergeable array, say interval, say we don't want to merge it, all we're just gonna append it, basically. So, looking at our example here, 8, 10, 15, and 18, these two intervals, they don't merge in any sort of way, so we're just gonna append it to our list of newly created intervals that we're gonna be outputting. So all we're gonna do is do new intervals dot append I, which is obviously our current interval. Intervals here, and we're just gonna append it if there's no merge in sight. So now all we have to do is return new intervals, which is our newly created interval 2D array that has all of the merged intervals now included, and we can test this out. So let's go here and click submit. Cool. We see that it was accepted and that the runtime beats about 86% of the other solutions submitted on LeetCode. Talking about the runtime a bit more, if we essentially look at the code, all we're doing here, like for the for loop here, is like it's a linear scan. We're going, big O of n over here. But what really takes, I guess, up some of the runtime is our sorting that we do in the beginning. That is an essential part because, as I've mentioned before, if we don't sort it, then, and for example, here we didn't sort it, and we have like 1 and 3, 8 and 10, and then 2 and 6. There's no good way to kind of go back and modify this 1 and 3 interval with the 2 and 6 because it would be quite difficult to manage pointers and whatnot. So sorting is essentially kind of necessary, and because of the sort, like a generic sort in Python, it would essentially be the entire algorithm or solution would be of n log n because of the sort. So that would be the big O. And yep, that is essentially the solution, runtime, and explanation. Hopefully that helped. Feel free to ask any questions in the comments, and if you want to see another LeetCode question explained by me, please mention it in the comments as well. Thanks so much, and good luck with your interviews.